So let's say we have this graph right here. For all of the x values before 0, the graph is concave down. And you might have learned before that if the graph makes like a frowny face, like this, then it's concave down, and if it makes a smiley face, then it's concave up. And while this is a good way to memorize it, the formal definition is that when f of x is f prime of x is decreasing, then the graph is concave down, and when it's increasing, the graph is concave up. And you can just see that because when it's concave down, it starts, the slope starts high, and it gets lower and lower, and the opposite for when it's concave up. And the point of inflection is where the graph changes from concave down to concave up. And you can find the point of inflection, or the points of inflection, by taking the second derivative and setting it equal to 0 or undefined. But just because you find the x value does not mean you find the point of inflection. You have to make sure that the values before and after x have different signs. And what I mean by that is like the sign diagram for f double prime of x should look like this. If you have your x value found right here, it should be negative, positive, or positive, negative. And when we do find the point of inflection, say the point of inflection is when x is equal to 3. If the sign diagram you make for this is positive, negative, then that means if it's positive, it's concave up. If it's negative, it's concave down. But if you have both positive, then that means there's no change in concavity. It's just concave up the whole time if both are positive. So for this example, what you would write for your answer for concavity is for concave up, it would be from negative infinity to 3, with a parentheses, not a bracket. And when it's concave down, 3 to infinity. And that would be the same for here, just negative infinity to 0 and 0 to positive infinity. And just a quick note, this won't affect the process of determining concavity, but for the point of inflection, it's only a point if the point on the original function exists. And what I mean by that is like, if you have a graph like this, where there's no value at x equals 0, but there's value everywhere else, the concavity changes when x is negative to x is positive. But there would be no point of inflection at x equals 0 because there's no point on the graph to place it on. If you had a point of inflection right here on this graph, for example, you could say the point of inflection is x equals 0 because x equals 0 actually exists on the original graph. Whereas on this one, it does not exist, and therefore there is no point of inflection. But this will not affect your actual process of determining the concavity. So first, let's do an example so you really know what the steps are to determine the concavity of a function. The first step is to look at the function and find the second derivative of it. So first, let's do f prime of x is equal to 12x squared plus 42x plus 36, and f double prime of x is equal to 24x plus 42. And there, we've determined the second derivative. And now we need to set it equal to 0 and undefined. But we can notice that if we set it to undefined, there are no solutions just by looking at it. So just set it equal to 0. And we get x equals 21 over 12, or negative 21 over 12. And now what we need to do is draw a sign diagram, because this is our only point of inflection at negative 21 over 12 for f double prime of x. And what we need to do is plug in values that are less than 21 over 12 and more than 21 over 12 into this expression to determine if it's positive or negative. So we can just see if it's, for example, if we plug it in 0, that is more than negative 21 over 12, and 24 times 0 plus 42, that is positive. And if we plug in negative 2, that is less than negative 21 over 12. 24 times negative 2 is negative 48 plus 42, still negative. So this is it. And now, since it's negative before negative 21 over 12, the concave is down, and when it's positive, it's up. So when it's concave up, it's from negative 21 over 12 to infinity, and when it's concave down, it's from negative infinity to negative 21 over 12. And that's our final answer for this function. So just a recap of the steps we did. We first determined the second derivative, set it equal to 0 and undefined, and determine when x satisfies that. Drew a sign diagram for the second derivative of x, and when it was negative, it's concave down. When it's positive, it's concave up. And we wrote our intervals as our final answer. Now, let's get into some practice problems. If you think you know how to do this one, pause the video and try it. This one isn't a question about concavity, but it says, find all points of inflection of f of x equals 2 minus x cubed. Now, again, a point of inflection is where the point exists on the original graph, and the second derivative at that point is equal to 0 or undefined. So first, let's find the second derivative of f of x. So f prime of x is going to be equal to negative 3x squared, and f double prime of x is equal to negative 6x. And we can set this equal to 0 or undefined, but if we set it to undefined, there's obviously going to be no real solutions. So x equals 0. This is our only point of inflection, but now we need to find the y value. So to find the y value, we plug in x to our original function, so 2 minus 0 cubed, and we get 2 for our y value. So the point is 0, 2. That's our answer, and that's our only point of inflection. Now, let's do another practice problem. If you think you know how to do this one, pause the video and do it. This one says, determine the intervals on which f of x equals x plus 1 over x minus 4 is concave upwards. And again, as always, the first step we need to do is find the second derivative of f of x. So the first derivative, f prime of x, is going to be equal to x minus 4 minus x plus 1. We can rewrite this as this without the parentheses. Get rid of these parentheses. All over x minus 4 squared. And this is equal to negative 5 over x minus 4 squared. And now let's find f double prime of x, or the second derivative. This can be rewritten as negative 5 times x minus 4 to the power of negative 2. So the second derivative of f of x is going to be negative 5 times negative 2 times x to the x minus 4 to the negative 3. This can be rewritten as 10 times 1 over x minus 4 to the third equals 10 over x minus 4 to the power of 3. And this is our second derivative. And we need to set this equal to 0 or undefined. And when you have a rational function like this, when you set it equal to 0, you can set the numerator equal to 0, and obviously this won't work. When you want to set it to undefined, you set the denominator to undefined, or the denominator to 0 instead. So we have x minus 4 to the power of 3 equals 0, but we can just get rid of the power of 3 because it's set equal to 0, and x equals 4. So we have our point of inflection, but this is not actually our point of inflection, because we can notice that in the original function, when x equals 4, it's undefined. So this is one of those cases where we still need to, this is still where the concavity changes, but it's not our point of inflection. So let's draw our sign diagram for f double prime of x, where x equals 4 right here. Let's plug in a value that's less than 4 into f double prime of x. So if x equals 0, which is less than 4, you get 10 over negative 4 to the power of 3, which is negative. And if you plug in 5, which is more than 4, you get 10 over 5 minus 4 to the power of 3, which is positive. So this function is concave upwards when it's more than 4, so the interval is 4, infinity. And that's our final answer. And just a note, on a test where you need to show your work, you should show more work for when you plug in, when you set your second derivative equal to 0. And obviously it should be more organized than this. When you set your second derivative equal to 0 or undefined, you should write each out individually instead of skipping them like I did. I skipped them because it's just a way to save time, but on the test, you should show all of your steps and show that you know that when you set it equal to 0 or undefined, it doesn't give a good answer. So everything that I just explained and all the problems that I went through should teach you everything you need to know about the basics of concavity of functions. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.